Good day, guys. This is your tutor engineer. Today we are continuing with part B on velocity time, position time, and acceleration time graphs. So let's start with today's lesson. A cyclist starts from rest and accelerates at 3 meters per square second. So this means that the velocity is starting from zero. That's what rest means in physics. So let's continue. For 30 seconds, he cycles easterly direction. Draw velocity time, position time, and acceleration time graphs at his motion. Indicate all necessary values on the axis. Okay, let's start by labeling the axis. This is the time axis. So time is measured in seconds. And then since we are given acceleration, so we're going to start by drawing the acceleration time graph, right? So this will call it acceleration in meters per square second. So let's just plot it right away. Okay, let's use a black color for plotting. So here we'll have 0, so it didn't pick up the black color. Okay, let's just, okay, you'll have 0, and then the time is 20 seconds. We can just say 0, 10, or okay, you can even make it more fun by saying 5, 10, 15, 20, right? So let's do that. It's 5, 10, 15, 20, and then the acceleration is 3, so we'll say 1, 2, 3. So the acceleration is just going to start from 3 going to 20. It's going to be an accelerating at 3 meters per square second. That means acceleration is going to be constant at 3 meters per square second, meaning our velocity will be increasing. So we can project that to the time axis to 20 seconds. So that's the acceleration time graph. So now let's go to the velocity time graph. Let's plot the velocity time graph. So when you do so, our time doesn't change much as in the acceleration. So here we'll just say 0, 5, 10, 15, 20 as in the acceleration time graph. And then now let's work out the velocity. Now we're given the acceleration time graph. In order to get to the velocity in meters per second, given the acceleration time graph, that means you need to work out the area, right? It's not the slope, it's the area. So the area under the velocity time graph will give you the acceleration. So if you want to go back, remember, if you want to go back given the velocity time graph and you need to work out the acceleration, that means you must remember that you need to work out the slope. So it's vice versa. So now let's work out the velocity. The area under the acceleration time graph. Okay, we know that the base here is 20 seconds, right? So, and the height is 3 meters per square second. So we can easily work out the velocity as V is equal to base times height. The base is 20 seconds. The height is 3 meters per square second. So this will give us 60 meters per second to the original direction, since we're dealing with the a vector quantity. So it's moving east, so we can just write here the motion is towards the east. Okay, so let's plot the graph for velocity time graph. The graph will look something like, initially, since the object is starting from rest, right, so the velocity will be 0. It will start at 0. Then after 20 seconds, it will have reached 60 meters per second. So the scale on the velocity axis, we can just say 20, 40, 60. So by the time it's 20 seconds, the velocity would be 60. So let's just join with a straight line. So that is going to be the velocity time graph. Now let's move on to the displacement or position time graph. This is the time axis in seconds. Change in x for displacement is measured in meters. Our time never changes. So the time axis will remain the same. Now, as we had spoken about before, that when you are given the velocity time graph and you need to work out the displacement in meters, that means you need to calculate the area. So let's calculate the area under the velocity time graph to work out the displacement. The height for this triangle is 60 meters per second, and then the base is 20 meters per second. So we can easily work out the displacement and say displacement is half base times height. Since this is the triangle, this is the area of a triangle's formula. So that's 1/2. The base is 20 seconds. The height is 60 meters per second. So our change in, or our displacement rather, is going to be, it's 10 times 60, which will give us 600 meters. Since it's positive, we'll say the direction is east, since this is a vector quantity. Now let's plot the position time graph. Okay, firstly, how are we going to accommodate the 600? So let's write here 200 meters, 400 meters, 600 meters on the position axis. And then the displacement will start at 0, and then it will increase almost exponentially. By the time it is at 20 seconds, the object would have reached 600 meters. So the graph, the corresponding position time graph, will look something like an arm or half an arm of a parabola, like, or a hockey stick, right? So it's something like a hockey stick coming like this. It's not really a straight line, so just imagine the hockey stick. That's how your position time graph will look. Okay, so that's it for today. We have come to the end of part B. If you liked today's lesson, please subscribe and stay tuned on the next lesson, where I'll be doing part C on the position, velocity and acceleration time graphs. There will be given a question of the position time graph, and we'll be asked how to plot the velocity time graph from there. So stay tuned for that lesson, and cheers.